Hello and welcome back. Today I'll be doing question 4 from the 2009 STEP paper 2. So this is a question about polynomials. Let's get started. The polynomial p of x is of degree 9 and p of x minus 1 is exactly divisible by x minus 1 to the power of 5. Part 1. Find the value of p of 1. Part 2. Show that p primed of x is exactly divisible by x minus 1 all to the power of 4. Part 3. Given also that p of x plus 1 is exactly divisible by x plus 1 to the 5, find p of x. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started. So, for part 1, if we write p of x minus 1 is equal to f of x times x minus 1 to the 5, where f of x is a quartic function, then we can write p of x is equal to f of x multiplied by x minus 1 all to the 5 plus 1. Therefore, p of 1 is simply equal to 0 plus 1, which is 1. Now let's move on to part 2. So, for part 2, if we have p of x minus 1 is equal to f of x times x minus 1 to the 5, then differentiating both sides gives p primed of x is equal to f primed of x multiplied by x minus 1 to the 5 plus 5 of x minus 1 to the 4 multiplied by f of x by the product rule and the chain rule. From this, we can factorize out x minus 1 all to the 4, and therefore x minus 1 to the 4 divides exactly into p primed of x as required. Now let's move on to part 3. So similarly to parts 1 and 2, we have p of x is equal to g of x multiplied by x plus 1 all to the 5 minus 1, where g of x is another quartic function. P of negative 1 is equal to negative 1, as in part 1. And also notice that x plus 1 to the 4 divides into p primed of x perfectly. Now, we need to notice that p primed of x will be of degree 8, and therefore p primed of x is equal to k of x plus 1 to the 4, x minus 1 to the 4, where k is a constant integer. So p of x is equal to k of the integral of x squared minus 1 all to the 4 with respect to x. Here, it's important to notice that p primed of x will be of degree 8 and therefore is a constant multiple of x plus 1 to the 4 and x minus 1 to the 4, as this allows you to form two simultaneous equations and solve for the two unknowns to give p of x. Now, if we integrate through, then we have p of x is equal to k multiplied by 1/9 of x to the 9 minus 4 over 7 of x to the 7 plus 6 over 5 of x to the 5 minus 4 over 3 x cubed plus x plus c. We can now write two simultaneous equations. K of 1 over 9 minus 4 over 7 plus 6 over 5 minus 4 over 3 plus 1 plus c is equal to 1, and k of negative 1/9 plus 4 over 7 minus 6 over 5 plus 4 over 3 minus 1 plus c is equal to negative 1. Adding these equations gives 2c equals 0, which is therefore equal to c. Now that we have c equals 0, we can substitute back in to, for example, the first equation and solve for k equals 315 over 128. Therefore, p of x is 315 over 128 of 1/9 x to the 9 minus 4/7 x to the 7 plus 6/5 x to the 5 minus 4/3 x cubed plus x. And that's my answer. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.